All right, in this video, I'm going to show you how to use set builder notation. Set builder notation, what we want to do is we want to realize that we're going to put this into a set. So what we're going to do is we're going to have these curly braces. All right, so let me set up an opening curly brace and a closing curly brace. And what we would say with set builder notation is we would put our variable. So let's start out and just say we're using x. So that would mean all x. So this means all x. And then if we put a vertical line, that this means such that, and then you have the option of how we're going to write this. So for example, if we wanted, I'm not going to do parts A and B yet, but let's just say in general, we could say, for example, x less than or equal to 2. Okay. So this means the set of all x such that x is less than or equal to 2. And then if we have stipulations on some subsets of the real numbers, we can add some things to this. So there's different ways to do this. Okay? All right, so let's do part A here. The set of all integers greater than 5. Okay, so one thing we want to realize here is that we're only looking at the integers greater than 5, so that we're going to have to make a extra step in this case. All right, so let's go to set of, we're going to say all x, vertical line. Now, one thing you can also do is you can also use a colon instead of a vertical line to represent such that. That's an alternative way to do it. Okay, and then we would say we want x greater than 5, so we're going to put x greater than 5. But in this case here, if we ended the set, this would be considered every value x greater than 5, but we want the subset of that. We just want the integers. So we would say comma, and then we would say x, and then this symbol here means, it's kind of like a curvy looking E. This means member of. Okay, so all integers, the integer set is represented kind of by this. Sometimes they have like an italics Z or a capital Z here. So that is representing the integers. And then we would put our squiggly brace. So this would read the set of all x such that x is greater than 5 and x is a member of the integers. Okay, now we can also use the word and in this case here. So we can put the word and instead of the comma. Okay? All right, so let's do example B. We have negative infinity to negative 1 or negative 1 to positive infinity. So in this case here, we are dealing with all the real numbers except negative 1. Negative 1 is not included because of the parentheses there. All right, so we could write this out as put our set x, all x such that x is not equal to negative 1 would be one way to write that. Okay, so that would be set builder notation for our first couple examples. So let's try a few others. Okay, in our next example, we're going to work backwards from set builder notation and we're going to sketch the graph. So problem number 4 says the set of all x such that x is greater than negative 6 and x is less than or equal to negative 2. Okay, so let's make a number line. Okay, so make a line here, and then we're going to have x is greater than negative 6. So if I put negative 6 on my number line, since we're saying greater than, I'm not going to include negative 6, so I'm going to have an open circle. And we say x is less than or equal to negative 2. So at negative 2, I'm going to have a closed circle because we're including the point, and then we would graph all the values between. Okay? All right, problem 5. We have the set of all x such that x is less than or equal to 0 or x is greater than or equal to 10. All right, so again, we're going to make our number line. And then on our number line here, we're going to have, let's put 0 here. And let's put 10 here. So we want x less than or equal to 0 or x greater than or equal to 10. So x less than or equal to 0, we're going to have a closed dot at 0, and we want all the values of x less than 0. And then on this side, x greater than or equal to 10. So we're going to have a closed dot because we have the equal part with the inequality. Whoop, try that again. And then we're going to graph to the right here. Okay, so that would be how to convert backwards from set builder notation back into a graph. All right, in our next example, we're going to write the set of numbers in set builder notation. All right, so we have close bracket -5, comma 16 parenthesis. So we're going to say curly brace x, all x, such that, and we're going to use compound inequality here. So we're going to say -5 is less than or equal to x is less than 16. All right. So we have all the values between -5 and 16, but we're going to include -5, but not include 16. All right. Similar problem 22. So we would say, now let's try a different variable. It doesn't have to be x every time. It could be whatever variable you want. So let's say you were doing a range. So you could say y such that, and now we're not including, we're between 22 and 98. We're going to include 98, but not 22. So 22 is less than y is less than or equal to 98. Right? All right, so now if we look at 23, we're going from -infinity to -4, hard bracket, meaning we're including it, or +4 to infinity. All right, so how would we represent that? Well, okay, let's go back to x. So we would say x, all x, such that, so in this case here, x would be less than or equal to -4. That would be this, this back from interval notation to inequality. So x less than or equal to -4, okay, or x greater than or equal to +4. So our or statement would carry over into the set builder notation. Okay. Similar example here. Let's use the variable y. So we're going to say y such that, so we want all the values for y such that we're going from 5 to -infinity. So y would have to be less than or equal to +5, or, and in this case here, we're going from 14, including 14, to +infinity. So y greater than or equal to +14. Okay, in our next example, we want the set of all integers less than -20. So we're not dealing with, we're dealing with a subset, the integers, not the real numbers. All right, so when I write this out, I'm going to say brace x such that, okay, x is less than -20. So x is less than -20. But now I have to make the stipulation that and x, and we use this curly looking, looks like the letter E with a little curve in it. That means x is a member of the integers, and the integers are represented by the letter Z. Okay? So that's specifying that we want all the values of x less than -20, but it has to be a member of the integers. Okay, it can't be all real numbers. All right, so we say the set of all real numbers greater than 19 and less than 32. Let's use a different letter here. Okay, let's use T. So all T such that, so we want greater than 19 and less than 32. So we can make a compound inequality here. Greater than 19 and less than 32. Okay, we could add the stipulation that t is a member of the real numbers, but we're going to by default we're going to say that it is a member of the reals here. All right, the set of all real numbers except 100. Okay, so let's go back to x, the set of all real numbers x such that all x except 100. Okay, so we're going to say x not equal to 100 is the only stipulation in the set. Okay. The set of all whole numbers except 50. So in this case here, we would say x such that, okay, x cannot be equal to 50, and we want the whole numbers. Okay, so we don't want the real numbers, so we have to be more specific. So we're going to say x is a member of, and we're going to use the capital W for the whole numbers. All right, and I'll put the chart up for the different number sets and the letters that we use here. Okay. All right, so I hope this video was helpful, giving you some practice on set builder notation. Thanks for watching. Please like and subscribe.